So here we have our basic code set up. I've asked the user to enter an int, and then we're pulling in the int using scan.nextInt. So now we need to set up the if statement. So if, now we're testing if it's between 45 and 78, but it has that not there. So there are a couple different ways we can do it. I'll show you both ways. The first thing we can do is say if x is less than 45 or x is greater than 78. And we'll just say not in between 45 and 78. So doing it this way is with an or condition. Now, again, it doesn't say anything about inclusive, so we want to go ahead and use the equal signs here. Okay. Basically what that says is if it's between 45 and 78, it's numbers like 46, 47, all the way up to 77. So let's compile this and run it and make sure that it is working correctly. So if we enter an int, again, we want to test our boundary cases. So I'm going to test 44. 44 is not in between 45 and 78. I'm going to test a number that is between 45 and 78. So let's test 60. And again, we don't get any response, which is correct. And let's test 79 now. 79 is not in between the two numbers. That's one way you could have solved it. The other way you could have solved it is using an AND condition. So we're going to actually first put the whole thing in parentheses here. So basically first we're going to make x between 45 and 78. So if x is greater than 45 and x is less than 78. So that's the opposite of what we're really looking for, so we can put that not symbol in front of it. So let's recompile. All right, no mistakes. And let's run with the same numbers. 44 is not in between 45 and 78. Running again, 60 is, so we don't get any output. And here when we run 77, 77 is in between the two numbers, so we don't get any output. Let's try one more. Try 79. And again, correctly, 79 is not in between 45 and 78. So sometimes these Boolean conditions can get pretty complicated. And so to help with that, we have something called a truth table. It's just a way of writing out all the possible combinations. It can help you solve some of the problems on the AP exam. Step 1, we're going to write out all the combinations of the terms. And then step 2, we're going to actually evaluate the logic statement for each of the combinations we worked out in the first step. So here's a simple example. Now, A and B are just a shorthand. So in the last problem that we saw, we were doing things like x greater than or equal to 45. In a situation like this, A just represents some value like that. And we can either have a value of true or false. So the first thing to do is come up with all the combinations of true and false for A and B. Now, sometimes you see these written as T and Fs. Sometimes you see them as 1s and 0s. 1 represents true, 0 represents false. I'm going to use the 1s and 0s. So the first combination is A and B can both be true, or I can have A true and B false. I can have B false and A true, or they can both be false. So for something simple like this, where I only have 2 possible combos, I basically come up with 4 rows in my truth table. And now we're testing the OR condition. So for the OR condition, either A or B has to be true. They can also both be true. So if A is true and B is true, then A or B is true. Here I have A is true, which makes that true. B is true here. And the situation where A and B are both false is the only way to make an OR condition false. So that's what the truth table for A or B looks like. Let's try another one. So here I've already written out the combinations of A and B. Again, they can both be true, I can have one or the other true, or they can both be false. And we have a slightly more complicated term over here. So I'm taking the opposite of A, not equal to the opposite of B. So if A is a 1, the opposite is a 0, and if B is a 1, the opposite is a 0. So what we're doing is we're plugging those values in and seeing if they're not equal to each other. In this situation, the opposite of A is 0, opposite of B is 0, and they are equal, making this part false. So the whole thing is false. Now here we take the opposite again. The opposite of A is 0, the opposite of B is 1. 0 is not equal to 1, making our Boolean condition true. We take the opposite of A for the next row, opposite of B. 1 is not equal to 0, making the whole row true. And for the last one, the opposite of 0 is 1, the opposite of 0 is 1. If I try to test for not equals, 1 does equal 1, which makes this last row false. Now I'd like you to try it. Go ahead and fill it out and see if you can get the correct answers.